Hey guys, welcome back. We got day 28, and all they're doing today is a bunch of Lewis examples, all right? My recommendation, if you have not done so yet, is to do all this, right? Do the whole thing, right? And then watch what you need to watch and just make sure everything's correct, okay? So, what are we doing? We are going to draw Lewis structures, right? We're going to get the electron pair arrangement or geometry, the shape, the hybridization on the central atom, if it's polar, and if there's resonance. All right, so that's what we're going to do in all of these. All right, so let's dive in. Hydrogen peroxide, 2 times 1 electron for hydrogen. Again, periodic table is needed, right? 2 times 6 electrons for oxygen. So you need, I don't expect you to memorize, the valence electrons for every element. I do expect you to know for the column, the group, and looking at the periodic table. So look at the periodic table. So we have 14 electrons. How is this arranged? Well, H is not a central atom. So I'm going to HOOH. Bond 2, 4, 6. No, octets. 8, 10, 12, 14. We check. Formal charge. Hydrogen is good. Hydrogen is good. It's got 1 bond. Oxygen. 1, 2, 3, 4, 5, 6. Has 6. Brought in 6. Good. And both oxygens are in the same spot. So it's good. Now, there are 2 central atoms. So both oxygens here. Both oxygens. Electron pair geometry. Well, we got 4 pairs. All right. 4 pairs. Tetrahedral. Shape is bent. Hybridization. They're both sp3. Polar. Yes, it's polar because they're bent. And then resonance. Is there any resonance? No resonance. NH2OH. Electron count. We have 5 electrons plus 2 times 1 electron plus 6 plus 1. That's 14 electrons again. How is this arranged? Well, I'm going to have maybe an H, N, 2 H's off the N, an O, and an H maybe. Let's try it. 2, 4, 6, 8, 10, 12, 14. How's that look? Well, I think it looks good. Formal charge is good. Okay, so we have 2 central atoms. I have N and we have O. N, electron pair geometry, tetrahedral. Same with O. O. Well, for shape, molecular shape, O is bent and N is trigonal, pyramidal. Then we have hybridization. sp3 for both. Polarity. Now, polarity is yes for the molecule, and resonance is no for the molecule. Right? So it's not, resonance and polarity are for the whole atom, not necessarily for a central atom. All right, ASO3, 3 minus. We don't have to know that polyatomic ion, but we're going to draw it. So now, electrons. Arsenic has 5 electrons, plus 3 times 6 electrons, plus 3 electrons. So that's what, 18. 26 electrons. All right. I got arsenic in the middle because it's written first. Let's electronegative. Oh. Let's try that. Let's see how this works. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to use a different color. 26. So arsenic has a lone pair. All right, is that good? Yeah, I think that's actually great. All right, arsenic's formal charge is 0. All right, and each oxygen's -1, total of -3. I like it. All right, so now it's just for arsenic. It's only a central atom. The electron pair geometry looks like it's 4 pairs, tetrahedral. The shape is trigonal pyramidal. All right, because arsenic is 2 underneath nitrogen, same group 15. Gives us a hybridization, sp3. Polar, yes, I would say it's polar. Resonance, especially in Chem 1, no resonance. All right, there's no other way to move the electrons around. All right, sulfurous acid, electrons. I have 2 times 1 electron plus 6 plus 3 times 6. So that's 26 electrons. Now, this is a ternary oxyacid, right? How do I know that? Well, it's an acid, H is out front, right? And it has oxygen in it. And you would name it, right? If you remember the naming rules, right? It's sulfite, so sulfurous acid, right? That's the naming system. And so all these ternary oxyacids, right? It's H bonded to O bonded to this central atom. Okay? So the central atom's S. I have 3 O's. Then we have 2 H's off of those O's. So let's bond. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I got 2 more. 26. All right. We got, get the highlighter out. I got these O's are central atoms. And of course, S is a central atom as well, right? S is a central atom. The other oxygen is not a central atom. Okay, so I have S, and I have the O's that are central atoms. Now, the electron pair geometry of S, I have 1, 2, 3, 4 pairs, tetrahedral. Same thing with the oxygens. The oxygen's got 4 pairs, they're tetrahedral as well. The molecular shape of sulfur would be trigonal pyramidal. But oxygens are bent. The hybridization of both are sp3. Polar, well, yes. Well, I used the wrong color. Resonance. Ooh. So I'm going to put no down, but we can minimize formal charge. So that means in Chem 1, we never consider this resonance, but it's resonance. All right? It's just like a great example is, when you have different soccer players, like when they're at certain ages, they can't head the ball yet, right? When they first start out, they don't really even hardly do corner kicks and free kicks and that type of stuff. You just let them play, right? It goes out of bounds a little bit, not the end of the world, all right? they get a little older, they can start doing the free kicks, they start calling fouls, but they're still not using their head. And finally, when they get old enough, they can use their head to actually, move the ball. Same thing here. We're not doing, this resonance yet, but what would the resonance be? Well, I can minimize formal charge right there. And so now, sulfur has no formal charge, oxygen has no formal charge, and we're happy. All right? So, no, but technically is yes, it's resonance. Yes, there's resonance there, it's just technically no. In Chem 1, we're not going to ask you that. All right, NO, nitrogen monoxide. I have 5 electrons plus 6 electrons. Gives me 11. All right, so let's look. 2, 4, 6, 8, 10, 11. Well, I can probably do this. All right. Now, I could have, let's use black. And we could do it this way. Right? What's the difference? Where the unpaired electron, the radical is, right? The best one is here because there's no formal charge. And here's -1, +1. So the formal charge is not as happy. All right. Let's do this. Electron pair geometry. So in Chem 151, we don't have a central atom. There's no central atom. So in our books, and every book I've done here since I've been teaching here, we do not have electron pair geometries. Now, there is a shape because it exists and it's linear. Now, another thing in Chem 151, and this is big, there is no hybridization for terminal atoms. Since there's not a central atom, we are not going to have a hybridization. Okay? We're not there yet. If you use the internet to look it up, you might find one, but that's not what we want right now. Okay? Polarity. Yes, it's polar because N and O. Resonance. Yes, because we just drew them both, the purple and the pink. Right? They're not equal resonance, so it's not going to be a resonance question for you on a test, but it's resonance. All right, dichloromethane. We have 4 electrons plus 2 times 1 electron plus 2 times 7. 20 electrons. Let's see here. C, H, HCl, Cl. Let's do something like that maybe. It doesn't matter where you put the C's or the Cl's and the H's, because no matter what, you're not going to get them opposite sides of the molecule, because how it works. 18 and 20. There's my 20 electrons. Perfect. Electron pair geometry is tetrahedral. The shape is also tetrahedral. Hybridization, sp3. Polar. I'm going to put the yes down because that's a top 5 and that's a top 5, right? And so no matter what, we're going to have polar bonds. Now, it's not that polar. It doesn't mix with water, but it's polar. Resonance would be no. No other way to do that. All right, moving right along to triiodide. Ooh, what do we got here? All right, we have, let's see, 7 electrons times 3 plus 1 electron gives us 22 electrons. I'm going to do this in a line. And let's try it. Let's try it. 2, 4, 6, 8, 10, 12, 14, 16. I kind of did that out of order. I'm sorry, guys. I already know the answer, so there you go. There's 22. All right. And so let's see. How's that look? Looks like the terminal eyes are good. And the central eye has 10. Not a problem. So how many pairs? Electron pair geometry. Looks like it's 5 pairs. Trigonal. Bipyramidal. Shape. Linear. Hybridization. SP3D, and you got 5 pairs. And then we have polar. I would say no. It's an ion, but not polar. And resonance, no resonance. All right. N3 minus. Azide. Electrons. 5 electrons times 3 plus 1 equals 16 electrons. All right. I'll try N again. Let's see. 2, 4, 6, 8, 10, 12, 14, 16. Ooh. So this one, I can double bond both sides. That's good. However, I could have triple bond one side, couldn't we? We could do this, couldn't we? We could have done that. That's good to know. All right. And so for the electron pair geometry of nitrogen, I would say that's linear. All right, 2 pairs, even though there's, right, the double bond counts as 1. The shape is also linear. Hybridization is SP. Polar, I would say no. Oh, I forgot the negative sign here. Sorry about that. Resonance, I would say yes. Resonance, right? There is a resonance here. All right. Fun stuff. 9. Xenon tetrafluoride. 8 electrons plus 4 times 7 electrons. 36 electrons. Okay. And so I got xenon and I got 4 fluorines. 1, 2, 3, 4. 2, 4, 6, 8. And then 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I missed 2. That's 32. Which means we got 34 and 36. All right. I like it. Electron pair geometry is octahedral. Shape. All right, it's octahedral because there's 1, 2, 3, 4, and then 5, 6. 6 pairs. Shape. 4 bonding pairs. It's going to be square, planar. Hybridization, sp3d2. Polar, no. Right? It's perfectly symmetrical because those are 90 degrees apart in a plane. Resonance, also no. Whew. Ooh. Thiosulfate. Let's see here. I have 2 times 6 electrons. That's actually, yeah, plus 3 times 6 electrons plus 2 electrons. Well, that's 32 electrons, isn't it? S in the middle. Two minus 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay. I think we can reduce this. All right, formal charge now. I just have these two oxygens at -1. All right, fantastic. Electron pair geometry of sulfur. Tetrahedral. Right, why is it tetrahedral? That's a great question. Right, remember, that counts as 1. That counts as 1. That counts as 1. And that counts as 1. It only has 4 pairs. Even though this really has 6 pairs, it really only counts as 4 pairs. Shape is also, oh, that's highlighted. Sorry about that. Shape is tetrahedral. Hybridization, sp3. Polar, yeah, I'd say it's polar. Resonance, yes. Because this double bond right here can go there and it can go there. So there's resonance. Propane. All right. 3 times 4 electrons. 1 times 8 electrons. That'd give us 20 electrons. All right, so this is a hydrocarbon. And your basic hydrocarbon, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So all our carbons here, your electron pair geometry would be tetrahedral. Shape, same thing. Hybridization, sp3. Polarity is no, they're not polar, right? Those are defined as nonpolar. And resonance is no. All right, octane. It's the same thing. Octane's the same thing, except it's got 8 carbons. So it's H, 1, 2, 3, 4, 5, 6, 7, 8. And then there's an H on every C up top and bottom. Now, technically, they're 109 degree bonds, right? 109 degree and a half, 9.5 degree bond angles. And so that means they're not just like this. But this is your carbon chain. Now, this is not usually the octane in gasoline, but it's octane. And it's there too. Same there. All right, moving on. Let's see next. All right, POC. Yes, we'll do this one, and then we'll go and do some other ones. So this last one here, I have 5 plus 6 plus 3 times 7. So that's 32 electrons, right? Yes, 21 and 11, 32 electrons. P's in the middle. O, Cl, Cl, Cl. Little side note here. A lot of people put oxygen to be in the middle right here. But just because it's written in the middle doesn't mean it is. Right? Because sometimes that's the central atom. But like this and this one's central atom. Why is P? Well, it's written first, least structural negative. When we put a carbon in the middle, especially, that's kind of how it's bonded, and so carbon likes to be in the middle. So if carbon's in the middle of a chemical formula, good chance it's still going to be in the middle of the Lewis structure. Oxygen's not, unless it has to be. All right, so 8 times 4 is 32, so you guys probably picked up on that. And so we have 32 electrons. So everybody gets 6 pairs, or 6 electrons, 3 pairs, and we have our 32. Now, electron pair geometry, tetrahedral. The shape, also tetrahedral. The hybridization, sp3. Polar, yeah. And then resonance. I'm going to say yes, because you can minimize formal charge. What do I mean? If I minimize the formal charge of oxygen and phosphorus, I have resonance. So I'm going to say yes. All right, let's do benzene. And this is always fun, these two in class, because try it, right? You got 30 electrons, right? You got 6 times 4 electrons plus 6 times 1 electron, so 30 electrons. Try it and figure it out. All right, try it and figure it out. All right. Hopefully you tried it and figured it out. You got carbons that are 120 degrees apart, or bond angles, because that's what trigonal planar is, and that's what this is. So this is a hexagon, and the interior angles of hexagon are 120. Now, I'm not going to be perfectly 120, just on the screen, but that's what they are. That's not, I'm some electrons short. I'm 6 electrons short right now. So what happens is there's double bonds that come in here. Every other carbon is double bonded. And so that has resonance. They're all sp2 hybridized, they're trigonal planar, and there's resonance. Now if we look at pyridine, you still have 30 electrons again, except you have 5 times 4 electrons, plus 5 times 1 electron, plus 5 electrons, gives us 30 electrons. And so pyridine is very similar to that of benzene. In fact, I'm going to cheat, because I can cheat here. If I duplicate this, bring it down, right, we're just switching out, what are we doing? We're switching out an N, and that N has a lone pair. That's all pyridine is. All right, same number of electrons. So it's still your 6-membered ring with resonance. And then there's 3 resonance structures of this, and this is naphthalene, C10H8. And so you have 10 times 4 electrons plus 8 times 1 electron, all right, for valence of total of 48 electrons. Well, again, tough, but if you look, you got carbon, 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 carbon. There's your 10. All right, and we're going to bond them in our 6-membered ring. Just like we did before. And then we've got hydrogens. 1, 2, 3, 4, 5, 6. Oh, I need a little bit more space. Perfect. 7. All right. So now, how many electrons do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. I have 10 more electrons. I have 5 more bonds to draw. So I'm going to put a double bond here, 2. Double bond here. Put a double bond there. Then I can put a double bond there. And I can put a double bond here. So there's a resonance structure of naphthalene. Now you have to draw another one. Go again, if you haven't, at least pause now and try it. Hopefully you've tried it. I'm going to come down and draw the other Lewis structure. So I need to basically move these double bonds. So I can put it there, there, and there. All right. And then what happens, delete that, and then I need to put a double bond there, right, and a double bond here. I guess they were there. That's another one. There's one more Lewis resonance structure, but there you go. There's another one. So you could do another one if you want. All right. So hopefully now that we're very comfortable with bonding, we're very comfortable with drawing these Lewis structures. All right, and that's going to be it for the day. If you have any questions, reach out. All right, reach out. And next time we're diving into a whole new topic. So take care, guys, and we'll see you next time. Bye.